Hello, for those who don't know me, my name is Eric. In this video about van conversion, I will explain my 12-volt DC electric setup. The information provided here is for general informational purposes only. When I started my research to determine how to do the electric setup in my van, I was trying to understand every pieces of the puzzle. This is the video I would have loved to find to help me in the understanding of the components involved. Take note that every component bought for the electric setup came with an instruction manual that you must read. Not following instructions could result in meltdown of components or fire. Take note that every principle explained here is good for a large van as well as a small van. First thing to mention is that the electric setup for my van conversion is completely separate from my vehicle electric system. This means that I do not charge my auxiliary battery with the vehicle system. There's a huge advantage for this if your vehicle is still under warranty. If you modify your vehicle's electric setup, they may void part of your warranty. You may want to verify this if you are thinking of going in that direction. The alternator is what charges the battery of a vehicle. I opted not to charge my auxiliary battery with the help of the alternator, not just for the possible impact on the warranty, but mainly because it would have required a lot of driving hours per day to charge that auxiliary battery. An alternator has a capacity which is designed to meet the charging needs of the vehicle, not to charge another battery that will supply a fridge and other electric camper devices. I opted to have an electric setup 100% self-sufficient on solar power. I will explain in an upcoming video how I evaluated that setup and what are the options. Key factors that were taken into account were that I definitely do not drive hours every day and I can stay several days at the same spot for surfing, hiking, diving or whatever. I love autonomy. Here are the components of my electric setup. Battery. I have used a single 12-volt auxiliary battery as well as a 12-volt auxiliary battery bank. In both cases, it was stocking the entire energy required for all my electric camping devices. In this video, I will refer to the battery, but I may also be referring to a battery bank. I will explain how to determine the battery capacity and talk about battery bank in another video. All electrical devices in my van are 12-volt devices, including the fridge. I will also explain this choice in an upcoming video. 12-volt DC devices always have a positive wire and a negative wire that will need to end up being connected to the positive terminal and negative terminal of the battery. We will see this later on. Solar panel. Again, there can be only one panel or a solar panel bank, still to be discussed in an upcoming video. The MPPT controller is what controls everything. It's the brain of the whole electric setup. It receives the electricity coming from the solar panel and charges the battery. It also distributes the electricity to all my electric devices in my van. Fridge, lights, fans, etc. It would also cut off the supply of power to my battery if there was an electric problem, including overheating of the battery. MPPT means Maximum Power Point Tracking. It's a newer technology than the traditional cheaper PWM controller, which stands for Pulse Width Modulation. Solar panel power is messy because it goes up and down continuously every few minutes as clouds and other things change the amount of sun hitting the panel. The controller smooths this out and does the important function of preventing the overcharging of the battery by limiting the amount and rate of charge to the battery. The algorithm of an MPPT controller is very efficient to do this. It can be more efficient up to 30% compared to a PWM controller. An MPPT controller is typically efficient about 93 to 97%, and a PWM controller is efficient about 75–80%. This means that less solar panels are required. I will talk about this in an upcoming video. Subscribe to see the sequel. Power distribution terminal block. To physically simplify the connection of all my negative wires of my electric devices, I use a power distribution terminal block. In some ways, this block has the same function as a power bar. You connect everything to it and you have only one wire to connect to the wall. The negative wires of all my electric devices are connected to that power distribution block. Everything connects to it, and I have only one wire connecting to the MPPT controller. Fuse block. In the fuse block, each device that links to it is associated with its own fuse. This is required to individually protect each device and the system against an electric problem. It is a similar setup to the electric panel in a home. The switchboard allows me to turn on or turn off the electric supply to each device from one central location. It's the bridge of the enterprise. The inverter is a component that converts DC current to AC current. AC current is the electric current type used for devices that we plug in walls. The inverter allows me to use AC devices in my van. The problem with the use of an inverter is that it consumes more energy from the battery than running directly 12-volt DC devices. The conversion from DC to AC costs energy. To save current and minimize solar panels and battery capacity, it is definitely more efficient to use 12-volt DC devices. I will talk about this in an upcoming video on optimizing solar panel needs and battery capacity. The kill switch is the switch I have never used and hope to never use. This switch cuts off the electric current from the battery. I installed it simply in case of an emergency should I need to cut rapidly the current from the battery. This would deactivate any power coming out of the battery. A quite useful switch in case of an overheating battery or a short circuit between the MPPT controller and the battery. So there are 4 ways to cut off the electricity in case of problem. 2 are automatic and 2 are manual. The 2 automatic are each individual fuse of the fuse block that would break individually for each device. The MPPT controller would cut off the current to everything as a main breaker. The 2 manuals one are the switchboard that allows to cut off individually each device, the kill switch that kills the electricity directly at the battery level. Plus, depending on the device, it may have its own switch. This may seem like a lot of protection, but I think that it is a case of better to be prepared than being sorry. After all, I sleep in my van. It is exposed to extreme heat, extreme cold, plenty of vibrations, and freaking potholes. I used plenty of electric wires. I chose red for positive wires and blue for negative wires. Those wires need to be of the proper gauge. To know what wire gauge to use, you must read the instruction manual of each device or use a chart or a calculator available on the internet. The gauge of the wires can be different from one device to another because it depends on the required peaks amps of the device and the length of the wire. Wire gauge is important to avoid malfunction of devices or wire overheating, which could be a fire hazard. The longer the wire, the more electrical resistance there will be. hence the need for a larger wire in such a case. The higher the amps required for the device, the larger the wires need to be, so wire gauge is important. Battery monitor. My MPPT controller monitors plenty of information about my system, including the battery. The state of charge is a capital information to monitor. The MPPT controller is not accurate on this, so I added an accurate battery monitor, and I simply love it. Temperature sensor. The temperature sensor's role is to monitor the temperature of the battery to shut it down in case of overheating. How everything is connected. At first, all this setup seems complex and require one to be a rocket scientist to build and connect everything together. However, this is not the case. You simply have to eat the elephant one bite at a time. The whole electric setup can be subdivided in a few subsystems. The divide and conquer technique. Battery connection. Everything starts from the MPPT controller. First thing to connect is the battery. But previously, the battery must be fully charged with the use of an electric charger using wall electricity. The solar panel must not be connected first to the MPPT controller. This would damage it. The battery must be connected first. As you know, a battery has a positive terminal and a negative terminal. The negative terminal of the battery must simply be connected to the negative electrical connection of the MPPT controller. It's the same for the positive terminal of the battery. It simply needs to be connected to the positive electrical connection of the MPPT controller. Those connections are made with the simple use of screwdrivers. Obviously, it is important that no electric conductive material touch both terminals of the battery at the same time. The same logic applies for the end of both wires while connecting them to the battery. Also, one important thing to do is to cover the positive terminal of the battery with something providing electric isolation. As said, at no time should the conductive material touch both terminals of the battery. If something like this occurs, there will be a short circuit. As a precaution to avoid this, I simply put a few layers of electric tape. That's it, the first connection is already made. The wires used are the ones provided with the solar power kit. If it's not already done, I suggest you subscribe to my channel. I will publish a video on how to properly secure a battery to avoid any battery damage while traveling, which can easily occur. In which case the battery is usually broken beyond repair. Temperature sensor installation. I have used two kinds of sensors. One that is simply left beside the battery and one that is bolted to a terminal of the battery. In both cases, they are connected to the MPPT controller. Solar panel connection. After that step, the solar panel can be connected. Again, the required wires were included with the solar kit. To understand how to install the solar panel without drilling any holes, I invite you to watch my video on this. After the solar panel was installed, I simply connected the wires to the solar panel and to the proper terminal of the MPPT controller. Again, there is a positive and a negative wire, and the ends of these cannot touch. I installed the negative wire first, then the positive. I now have eternal electrical power in my van. This is so cool and so easy to do. Wiring the electric devices. As explained previously, I used a power distribution terminal block to connect all the negative wires. Then I connected the single output wire of the terminal block to the MPPT controller. That's it, half the wires are connected. For the other half of the wires, the positive wires, instead of using a power distribution terminal block, I used a fuse block. This will protect the electric circuit of any malfunction. If something abnormal occurs, rather than damaging something, the fuse will break. In addition, for the positive wires, between the fuse block and my electric devices, I added a switchboard. This allows me to be able from a single place to activate or deactivate the supply of power to my electric devices. Here's an important tip. I always label each wire. It will be easier to recognize and connect everything if it becomes required to disconnect anything. I simply use paper, a pencil, and adhesive tape. Inverter connection. The inverter requires a lot of energy. Mine is a 700 watts. It must be connected directly to the battery terminal with two simple cables, one negative and one positive. It also has its own switchboard for an easy operating access. This video is the first one of a series about the electric system setup of my van conversion. Don't be surprised if all the videos of that series are not presented back to back. This subject may not be of interest for everyone, so I may alternate with my other subjects. Please write in the comment section to let me know your preferred subject for the next video. This will help me decide what I will present next. Please support me reaching 100,000 subscribers and leave me a comment to let me know from where you are watching this video. I'd just love to know about it. See ya!